This is week 13, so we're going to be going over the review this week, which we're not going to make a video for that since we'll be doing that in class, so you guys can ask questions and work our way through it. So only lesson for this week is actually lesson 111, which is starting our 12th and final unit, which should be very exciting to you guys. And we're dividing in scientific notation. So again, scientific notation used for really big numbers or really small numbers. You probably wouldn't say 5,000 in scientific notation. We could, but that's not a super big number with a lot of zeros that it makes a lot of sense. So we have these like astronomical unit, which is about 150 million kilometers. And if we wanted to figure out the distance between the Earth and the Sun, which is what we've done, or 93 million miles, we'll just keep it in kilometers. For instance, Saturn's orbit, when it's about 1.5 billion kilometers from the Sun, its distance from the Sun is 10 AU. So 150 or 1.5 billion kilometers times 1 AU equals over 150 million kilometers. We cross out a lot of zeros. 1 and 5. 1 0 times 1, which gives us 10 AU. But we can also use scientific notation. So we could do it this way. It's still the same value. We're not changing the value. We're just usually making it easier on ourselves. So for really big or small numbers, sometimes it's easier to use scientific notation. So we would set up like this, or we could use scientific notation. 1.5 over 1.5 cancels out. That's just 1. 10 to the power of 9 over 10 to the power of 8. Well, same base, so we subtract 9 minus 8 is just 1. Kilometers and kilometers cancel out, so we're left with 10 to the power of 1 AU, or just 10 to the power, or sorry, 10 AU. You can put the exponent 1, but you don't need to, because you don't do that. So when we divide numbers written in scientific notation, we divide the powers of 10 by subtracting their exponents. That's one of our exponential rules we talked about. Since they're always going to be base 10, they're always going to be the same base, so we know we can just subtract their exponents. So let's take a look at this. So for A, we have 6 times 10 to the power of 8 over 1.2 times 10 to the power of 6. So we can start wherever we want, but I think it's easiest to start with our coefficient. Turn there so we don't have to keep flipping back and forth to the screen. Let's clear this up. So we got 6 is 10 to the power of 8 over 1.2 times 10 to the power of 6. So 6 divided by 1.2, those coefficients. 6 divided by 1.2 is actually 5. 10 to the power of 8 divided by 10 to the, we could write this as 10 times 10 times 10 times 10, 8 times and 10 times 10 times 10, 6 times and cancel out 6 of them top and bottom, and we'd be left with 2. Or we can remember the rules of exponents. Since they're the same base and we're dividing, we do 8 minus 6, which we know is 2. So 5 times 10 squared, 10 to the power of 2. Or 5.0, that's fine. We don't need to include the decimal since it's a whole number. This one we get, let's take a look, we get 3 divided by 6. Since this is just a big number and we're multiplying, and this is a big number that we're multiplying, or sometimes it'll be a small number, but we can look at our coefficients and reduce those. So 3 divided by 6, that's 1/2, or we'll call it 0.5 since we know scientific notation, we work with decimals. Then we look over here, 10 cubed divided by 10 to the power of 6, 3 minus 6 is actually negative 3. And again, we know our coefficient here has to be 1 or greater and less than 10. Basically, we need to have a value in the ones place and everything else to the right of the decimal. So right now we would have a 0 in the ones place, so we need to move this decimal. So we need to make it 5. We call it 5.0. Can't just move this, and that changes our whole number. So when we move that, that's the same as multiplying by 10. We could write it as 5 times 10 to the power of negative 1, since that would be 0.5. And then this 10 to the power of negative 1, we're going to do negative 1 plus negative 3 because we're multiplying those together. So we get 10 to the power of negative 4. So these and these look nearly identical, and they are very, very close, but this is correct scientific notation. 5 or 5.0 times 10 to the power of negative 4. Now what I remember is I move the decimal to the right. I'm basically multiplying by 10, so I need to divide by 10 or take 1 away from the exponent. That's the easiest way for me to do it, but if you want to rewrite this as this number and then multiply it all out to get to here, either way, it's going to be the same thing. So 5 times 10 to the power of negative 4. All right. Example 2, the distance from the sun to Earth is about 1.5 times 10 to the power of 8 kilometers. Light travels at a speed of about 3 times 10 to the power of 5 kilometers per second. About how many seconds does it take light to travel from the sun to Earth? Let's clear this out. Let's first set up what we're doing. So our distance divided by our rate should give us our time, which is what we're looking for. 3 or 3.0, we'll just call it 3 times 10 to the power 5, and this was our rate, so we know kilometers and kilometers are going to cancel out, so that's good. We can use seconds that we're going to be left with. 1.5 divided by 3 is 0.05. At 10 to the power, so we did this part first. Now we're looking here, 10 to the power of 8 or 10 to the power of 5. 8 minus 5 is 3. And then we move this to the right. It means we're multiplying by 10, which means we need to divide by 10 or take 1 away from the exponent. So we write it as 5 times 10 squared. 10 squared is 100, so 5 times 100 equals 500 seconds, which is what we ended up with. And again, we divided that by 60. It's 8 1/3 or 8.3, just over 8 minutes. So probably heard people say if the sun went dark or exploded or whatever, not that that's going to happen. But if anything ever happened to the sun, we wouldn't know about it for just a little over 8 minutes, because that's how long it takes the light from the sun to travel to Earth. All right, this practice that we'll go over, we worked with multiplication, so don't forget how to do that. It's just working with our coefficients, multiplying and dividing. And then our rules of exponents, when we're multiplying with the same base, we add the exponents. When we're dividing, we have the same base, which we obviously always will. We subtract the exponents. Okay. All right, we'll see you guys in class.